Next is the piecewise defined functions. Piecewise defined functions. What are these functions? The piecewise defined function is given by f of x is equal to f1 of x for interval 1, f2 of x for interval 2, then fn of x for interval n. But take note guys that the 1, 2, n on the subscript are not necessarily in order. These are not necessarily in order. Okay, it doesn't follow a sequence. This is just for the sake of notations. Okay, for the sake of stating the piecewise defined function. Example, f of x is equal to 3 minus x squared if x greater than or equal to -1, and x minus 2 if x less than -1 is an example of a piecewise defined function. Also, if we have g of x is equal to -6 if x is less than or equal to -3, 2 if x is between -1 and 4, but -1 is included but 4 is not, 5 if x is greater than or equal to 5 is another example of a piecewise defined function. In fact, the absolute value functions are also examples of piecewise defined functions. Take note, the absolute value functions here, this is an example of a piecewise defined function. Same here. Okay, this one. Okay, this is an example of a piecewise defined functions. Now, let's try to graph. Let's try to graph the first example. This one, f of x is equal to 3 minus x squared if x is greater than or equal to -1, x minus 2 if x is less than -1. Take note guys, this one here is a quadratic function which we have just discussed a while ago, and then x minus 2 is a linear function, and for sure you already knew how to graph this kind of function. Now let's try to graph this one. First, on the condition x is greater than or equal to -1, so we will use this one as our reference. So instead of graphing the way we used to graph functions, to graph quadratic function, we can just substitute values of x here so long it is within this condition, x is greater than or equal to -1, like we have just done in the absolute value function. So here, when x is -1, so when x is -1, our f of x, which is 3 minus x squared, is 3 minus -1 squared, that is 3 minus 1, that's 2. Okay, 1, 2 here. Okay, So this point here is negative 1, 2. Then we can choose another point. Let's say this one, 0. When x is 0, our f of x is 3 minus 0 squared. That is 3 here. So this point here is 0, 3. How about this one? 1. When x is 1, okay, you know guys, the a here is negative, and we know if a is less than 0, the graph of the parabola is opening downward. So obviously this is opening downward, but we have a restriction for x greater than or equal to negative 1 only. So when x is 1, this is 3 minus 1 squared, which is 2 here. So basically, if we connect that one, this is our function, which is f of x is equal to 3 minus x squared. The other one, when x is less than negative 1, so here f of x equals x minus 2. When x is negative 1, what's the value of f of x? That's negative 1 minus 2 equals negative 3. So we have 1, 2, 3 here. Here. But that's not a shaded circle because the condition x is less than negative 1. It's not less than or equal to. So negative 1 is not included. So the ordered pair there is negative 1, negative 3. Then try to use another value of x here, which is negative 2. When x is negative 2, that is negative 2 minus 4. Minus 2, that's negative 4. So here. So this point here is negative 2, negative 4. Then connect the points. That is linear. So that's a straight line. So this function here is x minus 2. Now, what is the domain of the function? So the domain is extended to negative infinity here, and on the right side that's extended to the right to the positive infinity. So the domain here is all real numbers. So how about the range? The range, take note that it's from negative infinity because of these arrows here to this point. That's 3. So that's 3 and 3 is included. So the range of that piecewise function is from negative infinity to 3. How about the second graph, the second example? G of x is equal to negative 6 if x is less than or equal to negative 3. Then 2 if x is located between negative 1 and 4. Then x is 5 if x is greater than or equal to 5. Okay. These are constant functions. So first, it's negative 6. 1, 2, 3, 4, 5, 6. It's a constant function. But x is less than or equal to negative 3. So we have 1, 2, 3. So we will start from here. So we will erase this one. Okay. This is g of x equals negative 6. Then next, between negative 1, this is negative 3 here, to 4, 1, 2, 3, 4, it's 2. So we have 1, 2. So from here, negative 1 is included. Oops. From here, negative 1 is included to 4, but 4 is not included. So that's the function. So this graph here is g of x equals 2. Next, x is greater than or equal to 5. So here, and that is 5. 1, 2, 3, 4, 5. Okay, this is 5. But we start from 5 here, and 5 is included. So from here. And this function here is, it should be g of x. So this is g of x is equal to 5. Now what is the domain? The domain from here is negative infinity to 3 union. From here, that's negative 1 to 4, but 4 is not included. Then union from 5 to positive infinity. That's the domain. And then the range is, these are just singular values. The range are negative 6, 2, and 5.